Good morning, class. How are you? Class, this is the second lecture of electronic configuration. In lesson number 6, we learned the shells and the maximum number of electrons that can be accommodated in those shells, and we also knew about the subshells S, P, D, F, which are the subdivisions of shells. And we also saw that the subshells are of different energy levels. Similarly, as the number of shell increases, the energy of that stationary state also increases. So, electronic configuration is the art of distribution of the electrons present in any atom into different orbits and in different suborbits or subshells. So here we see all the time we are following a pre-decided order, which is also known as Aufbau principle. We see this order helps us in assigning and accommodating and fixing or simply placing the electrons according to increasing energy levels. So we see the orbits remain there and their energy differences still there, but we have to see how we can write this electronic configuration. You see, the Aufbau principles tell us first subshell, which is available for placing electron in it with minimum energy level is 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, 4p, 5s, 4d, 5p, 6s, and so on. How we are going to attempt it? Look, all the time we are moving on diagonal lines, which we can also draw. Like first we write 1s, or we just write 1, then followed by second orbit. This number, whole number 1, 2, 3, 4 and so on, is basically describing the number of shells. So you remember we studied about K, L, M, N. So for K shell the number of N is 1, and for L shell the number of N is 2. Similarly for M 3 and N 4 and so on. So first we write 1, 2, 3, 4, 5, 6 in a column. Then we see the first shell has only one subshell, and that is S. The second shell has two subshells. The third shell has three subshells, S, P, D, and fourth and onward fourth, all the orbits having four subshells. So the first shell K has only one subshell, S. Then the second one is two subshells, S and P. The third subshell is having the third shell having three subshells, S, P, D, and the fourth shell having four subshells. All subshells are there, S, P, D and F. And from fourth onward to higher energy states, there are four subshells in every shell. So here we see them again. Now we have to write the right order. I told you that all the time I used to write my own order. I make my writing, whatever I taught you, like 1, 2s, 2p, 3s, 3p, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 7s onward. So first I write them, then the real art is to write the diagonal lines. You start from the top. The first line is crossing 1s. The second diagonal is 2s. The third diagonal is crossing 2p, then 3s. And the fourth one, 3p is coming, then 4s. In this case, you can notice that your order is going diagonally. In fact, practically we don't know why the number is changing, why the number of subshell is changing, but this diagonal relationship is written on the basis of increasing energy level. So we get the right order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, and so on. So you can write your own order for this. The next thing is, you have to remember all the time that S subshell can have only 2 electrons, and the capacity of P subshell is 6 electrons, and the place for d orbitals or subshells in only 10 electrons, and for F it is 14. So the maximum number of electrons they can be filled in S, P, D, F is 2, 6, 10 and 14 respectively. Now it's time to apply them. Remembering the trend or the order, you have to see which element is to be written in its configuration. You see, the hydrogen is having atomic number 1. You can read this 1 from the periodic table. Now you have only 1 electron to be placed in its shell, and in the right order, the first subshell to be filled is 1s. Don't forget that you can add 2 electrons in the s orbital, but luckily you have only 1 electron in this atom, so its configuration is 1s1. Next we have helium. Again, you look in the periodic table, the atomic number of helium is 2. So this time we have 2 electrons to be placed. You see, don't forget that your S subshell can have maximum number of electrons 2 in it. So we fill both of the electron in the very first subshell. So we get our configuration 1s2. Right? The next example is sodium. Now see, the sodium has 11 proton number and it has 11 electrons in its atom. So the right order goes, out of 11 electrons, now listen to me carefully, out of 11 electrons we will be filling them or dropping them into their right places according to increasing energy. So the first 2 electrons will be dropped in 1s. So it becomes 1s2. Then out of 11 we are remaining still with 9 electrons. Then the next place is 2s. Again, S subshell can hold up to 2 electrons. Again we place 2 electrons in it. Now out of 11, 7 electrons are left. Then the next subshell comes is 2p. So P can hold up to 6 electrons. So we drop 6 electrons there. And out of 11, we are left with only 11th electron, or only one electron is there. So the next orbital is 3s. So we drop it in the 3s. Don't get confused with the number of electrons. They can be accommodated in 6. You have only 11 electrons. So you distribute them into the right subshells according to their increasing energy level. So it goes 1s2, 2s2, 2 plus 2, 4, then comes 6, it's giving 10, and the 11th and the last electron is going into 3s1. Why this 1 is given? But the last subshell S is having only 1 electron. The next example is potassium. Potassium has 19 electrons in its atom, and according to Aufbau principle, it is filled in 1s2, then 2s2, then 2p6, 3s2, then comes 3p6, and the last 19th electron is going in 4s. Again, don't forget that you have only 19 electrons. Otherwise, if you have 20 electrons in it, then you will be filling 4s2 like this. The next is oxygen. You see, you have only 8 electrons this time. The first 2 electrons are going in 1s. The second 2 electrons are going in 2s and 2p4. 2 plus 2, 4, and 4 plus 4, 8. Because the atomic number is just 8. The same configuration is repeated in the case of sulfur. Sulfur has 16 atomic number. So you have 16 electrons to be placed. Then you begin with 1s2, 2s2, 2p6, 3s2 and 3p4. When you count them, 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 4, 16. So this is what you have to look again in the periodic table, that all the time when you are writing the electronic configurations, the configuration of elements are repeating. Not this whole order, only the outermost electrons are filling here in s orbitals. Here the elements are showing their outermost electron in p subshell, in this case d subshell, and in this case f subshell. So you will notice that the number of electrons present in the outermost shell is the same in case of groups as in the case of sodium. Sodium has 11 electrons. Its outermost configuration is 3s1. But in case of potassium, it is 4s1. So we see them in the periodic table. Sodium is here, number 11, and potassium is here. Sodium is showing 3s1 outermost and potassium is showing 4s1. So there are many more things to be cleared and understood, but let the topic come. Up till you have to write today's assignment as the first 20 elements from the periodic table. You just practice writing their electronic configuration and use my lecture, and from your textbook don't get the answer directly, just practice it and then tell me what you have done. Thank you so much. God bless you. Goodbye.